Hello, this is Joe Neville, and in this video I'm going to be talking about interacting with the REST API on Aruba AOS-CX using Python. Now this is a talk for beginners, but it doesn't just cover beginners content. What I've done here is I've included some of the things, some like hints and tips that I wish that I had known when I was starting out learning Python and trying to use APIs, and specifically APIs on networking kit. Now, the reason being is because if you are going to learn Python, you pick up a Python book or you're doing a course, you'll learn lots of important things, but it might not be relevant to the specific task that you want to do. In this case, interacting with an API. So we cover things like there's a bit of security in there. I do a bit of hierarchy, talking about whitespace, JSON, parsing JSON data that comes back from an API, loops and lists and the different data types. So, you know, in the short space of time that I deliver this talk, we do cover a lot. It does travel at quite a speed. Now, the background to this talk is that this is the content that I delivered at a couple of virtual events recently for HPE. So Aspire, and most recently HPE Discover. I was working with my colleagues in the HPE Hack Shack. Hack Shack are the people that run coding workshops and talks at HPE events, and they asked me to provide some Aruba content. And a really cool thing about this is that they wanted their talks and workshops, even though they were virtual, they wanted them to be interactive. So what they did is they set up the infrastructure for Jupyter Notebooks. So we can run Jupyter Notebooks. If you're not familiar with these, essentially these are a combination of markdown and code, which means that you can present a document that's like a live document that you can run the code in. They're really cool if you haven't used them before. I wasn't too sure about them to start with, but now I've used them, I see how great they are. So what we're going to do, because I did say that this was a beginner talk, what we're going to do is we're going to start off showing you how to get hold of the notebooks and how to fire those up so that you could follow along with this. That's a useful skill in itself. And then the main part of the talk is going through the REST API. So the task one then obviously is to get the notebooks. Here it is. It's been posted to the public GitHub. So it's github.com, Hewlett-Packard, HPE-notebooks. I will put a link in the description. And just like with normal with GitHub, we hit the code there, we copy. I'll open up my terminal. Here is my terminal, so I do a git clone, paste that down, and that will bring all of the notebooks down. There's only 2 on there at the moment at the time of recording, but there should be more soon. We do an ls, we can see, okay, we'll just move into the notebooks there. Let's do an ls in there. You see API 101. And my one that we're going to use here is the Aruba one, of course. So if we look at that, you can see, and it's this file here. The IPYNB is the notebook. Okay, so the way that I'm going to run this, because my notebook uses the third-party library requests, I need to install that, and rather than install it onto mine using my Mac here, I always use a virtual environment. I recommend that you do too, and you can run Jupyter Notebooks in a virtual environment. So I'm going to set up a virtual environment. Okay, ls, you can see that in there now. Now we need to activate that. So it's bin and activate, good, pip install. And it's Jupyter Lab for this. Install that. That takes a while, so I'll skip forward. Okay, that is now installed. And the other install that we need is requests. Okay, I just wanted to add a note in post-production that you don't have to do the requests install separately. Requests is a dependency of Jupyter Lab. So all you have to do is the pip install Jupyter Labs, and then you'll get requests as part of that install. Okay, I didn't pick that up as I was going through this live. Sorry. Okay, that looks good. And to start up, because we've got this local, to start up the notebook, I'm going to start it up with Jupyter Lab. This is the newer version, I think, the newer iteration of Jupyter Notebooks. It's more of an environment, I believe. That's what I'm going to use. So it's Jupyter, even though I noticed this, in all the marketing, it's Jupyter, no space, and lab. But when you have to run it, it's Jupyter space lab. Okay, so here we are. On here, I'll close down my old version. So you can see you've got the pictures there which render. You have the virtual environment that we're running out of. And here is my notebook. So I will expand this a little bit. And we'll go through the workbook. It starts off, it's kind of like the documentation that I would write for someone if they said, teach me how to start, like a how-to guide starting with the AOS-CX API. So this is what it is here, like lots of steps there. And starting with Swagger, because Swagger is the first point to actually interact with the API. So for those that don't know, I will show you Swagger. Here I am on the standard web interface of, this is a hardware, rather than the OVA, this is a hardware 6300 that I've got in my home lab. Now to access the Swagger interface, we hit the cog, top right up here, and we've got the two versions of the API. We'll open up the latest one. Now that's loaded up, so we've got CX REST API here. A quick word about Swagger. So this is an open source framework. So it's got nothing to do with Aruba or network automation per se. Like a lot of things in networking nowadays, it's been brought in from another area of IT and is being used by networkers. So what is Swagger? Well, it acts like a GUI for an API. Now, if you think about this network operating system, CX, it has a huge feature set. So it's layer 2, it's also layer 3. It goes from edge to core. So you've got all of your security, you've got all of your BGP, OSPF, EVPN, VXLAN, all of these good things. It's all configurable, all exposed via the API. So documentation, if you're going to print that out for this API itself, quite apart from the configuration guide, it'd be absolutely huge. So Swagger provides a much easier to consume interface so that we can learn what we need to. I mean, Swagger, why I'm starting here is because Swagger is where you would start if you were going to kick the tires with an API to get the information that you need and then use that to write your code, okay, so that we can interact programmatically with the API. Really nice thing is that it's live, so it's not just the documentation, like it doesn't just give you samples of what we need to interact with the API, but when we send a test call, well, like an example call, the data that comes back is actually the live data. So this one that I've logged into, you can see the IP address up there. That's a device in my home lab. It's a 6300. So when we execute a call, the data coming back is actually the data off of my live device. Right, so going down, here are the families of the different features that we can interact with. So we've got BGP, we've got DHCP there, all exposed, EVPN. We're going to start with a really easy one. So we'll start with firmware. If I expand that, and then we've got the different types of calls that we can make. Now, what I say is that there's 3 different pieces of information that you need to when you're interacting with the API if you then want to go and write your code, okay, to write your calls. So first of all, we need the HTTP verb, okay? So this is like the action that we can perform with our call. Again, coming from a different area of IT entirely. Nothing to do with networking. This is HTTP. And so we have these command words or these verbs. We've got get if we want to get information. We've got post if we want to post new information, so new data to the API. We've got put, get this right, we've got put if we want to update existing data on the API, and we've got delete if we want to delete. There is patch, but we don't have that with this API. So it's get, post, put, and delete that we can, the type of call. Then we need the URL that we're going to send our call to. So we just have the suffix there, so the last part of the URL, but we can get that from Swagger. It will show us that in a moment. And then the third piece of information that we need is the data that's going to come back from the API. That's vital because we need to know what format, so it comes back, it's JSON, okay, we'll go into that in a moment, but it's the, how is the data structured when it is returned to us, we can put that into our code, because then we can do something with the data. And that's the important point. That's where the automation comes in. Okay, so what we'll start with then is just a get. So we're going to get the firmware. If I expand that, this gives us all of the useful information, but we can try it out. So there's this button over here, try it out, and then we execute, and that will actually send a call to the API. We've got curl, so if you're familiar with curl, you can translate that into your programming language. Of course, we're going to be using Python. So here's the request URL. So we've got our verb, our HTTP verb was a get. We've got our request URL. So you can see it's HTTPS, and then we've got the IP address. Don't worry if you are afraid of the 128-bit address space that is v6. I'm just using v6 because that's what I've got in my lab. Okay, so you can use v4. That, and you may be wondering why is it in a square brackets, because v6 addresses need to be in square brackets in URLs. Okay, so what we've got, HTTPS, we've got the IP address, that's the management IP address of my device. REST, this is the type of the API, the version of the API. So the version is 10.04, and then the suffix of firmware. Okay, so that's our URL that we're sending to. And then we've got our response. Oh, actually, it's come back. It's come back as unauthorized. So that's a really great start. Let me try that again. Right, live demos and all that. So what I did is I just logged in. I've cleared my sessions. There we go. So this is what I was expecting. It's a 200. Okay, so we get back from the API what we're looking for is a different status code. So we've got a status code of a 200, and then this is the third piece of information that we really require, which is the response body. So this is these are the image names essentially. So we're running 10.4.10, and the primary version is 10.4 3000. I've booted off the secondary for these purposes, which will be revealed later. Okay, so that's using Swagger. Okay, that gives you some kind of interactive documentation that we can then go and do much more exciting things, which is to write code, and that's where we're going next. So I'll jump back over to my notebook. I've included interacting with Swagger as task 0, and I've given lots of details, you know, and lots of lovely diagrams about how to interact with that. But that's not what this video is about. It's not what this talk is about. In this talk, what we're doing is much more fun. So we scroll down past all of those big pictures. We come to task 1, which is using code to interact with the API. Now, the API is no different from any other networking device in terms of the first thing that we need to do when we want to interact is we need to log in, okay? So we log in using the username and password, but it's also really important that we log out with the API, and I'll explain why in a moment. So here's the code sample that we've got. Maybe I should make this a bit bigger. Okay, let's make it, yeah, that's a bit bigger. Okay, so here's, where's that gone? There we are. Right, so I put some notes in there, and what we have then, breaking that down, is we've got some imports for requests. We've got the destination IP address. Again, it's v6, as I mentioned. We've got our credentials, which is our username and password to log into the device. Not particularly secure. I'll talk about that in a moment. We create a session, and this is where we start to build our call. Okay, so here we are we've got a post. So remember the HTTP verbs that I was talking about? For a login, what we need to do is we need to send new data to the API. So that's a post. Then we have this, which is our URL. And essentially what I'm doing here is I've combined the IP address from up here. This is a variable that then goes into the URL. Which sits in, so you can see it's HTTPS, we've got the IP address, REST, the version, and then the suffix is login. So we saw firmware before, now we're logging in, okay? And what I'm going to do then is I'm going to take the status code, which hopefully won't be a 401 this time. I'm going to use the status code. We're looking for a 200. I'm going to print it to screen, and then I'm going to log out. Okay, now, so this is the first time I've used, I'm showing this, sorry, of course I've used it before, but if we highlight the notebook, so you've got this blue line, and you can go run, and you can run the selected cell, or the shortcut which I'll be using is where you do shift enter. Okay, so I'm going to run that cell, and that actually will run the code. So we've got the code runs in the workbook, and then you have the output. Okay, so we've got printed to screen, login code is 200 and logout code is 200. So that's actually interacted with my live device sat at this IP address. Okay, I've included it again. So moving on to the next one, I've taken the notes out, but a really important point here, okay, is the fact that we're not just logging in and then logging out. There's actually much more going on behind the scenes, okay? So let me run this next block. So I do a shift enter, and what we can see here is that we've got a cookie. Okay, so you've got this cookie here. Now the thing is, so we've logged in, and these are stateless calls. So it's not like there's an open channel that then all of the subsequent calls can use, interacting between the client and the server with the API. What you have is that you log in, and then you get a cookie back. So it's like an access token. Okay, it comes back, it's like your security pass, and what you do is you combine that with your subsequent calls. So you log in, and the API, if you're successful, you get the status code 200, and then you get a cookie back, and you combine that cookie with the next call. So to say, like, I've got authorization to access this API, and here's some extra information that I want. But the point is, with the login and the logout, that just like the real world, there's only so many cookies to go round. Like, not everybody can get a cookie. So what you have to do is you have to log out with the cookie in a call, and that returns the cookie. So there's only so many cookies. I think it's 3, and there's an inactivity timer of about 15 minutes. But when you're writing code, if you're doing a bit of trial and error with your code, it's really irritating to lock yourself out. So what you really want to do is you always want to be logging out. Okay, and that's the same with lots of APIs. So the first task when you are interacting with a new API, I suggest, is to learn how to log in and log out to return that token or that cookie. Okay. Now, what's going on behind the scenes is that in some people's code, you might see that they actually create a variable for the cookie. We don't have to do that because we're utilizing something with the fun name of a cookie jar. Okay. So I'm using the request library, which is handling lots of the low level interactions and makes it nice and easy for us. We sit at a higher level of abstraction because we're using this library. So what I've done is I've created this session, and then the session will store the cookie, and we'll be able to use that. So we don't have to include the cookie in our subsequent calls. We just use the session, and that will reuse the cookie. So that's what's going on here. Okay, now a word about security, because the eagle-eyed of you, and I hope there's some, will notice that in these calls I've done a really bad thing which you should never do, and that is, of course, I've included my password. So it's my username and my password are clear on the screen. This is not good, so never do this anywhere near an important device, okay? Especially not in production. But the thing is, with scripting, with using an API, it doesn't mean that you have to compromise your security position, right? There are ways of hiding your password or storing it somewhere where it can be retrieved. Lots of beginners don't use that, or they think, oh, I'll tidy that up later on. It's really important that really from the start you are thinking about security. So you're not doing things like putting your passwords into your scripts, okay? Do not do that. Right. Now, so there's multiple ways that you can get around this. So I put in a few words about security. Some ways that you can do this are, the first one I've included is environment variables. So in your operating system, you can create an environment variable and your code can then access that. So all you will see is your code accessing the environment variable. You won't actually put the password on the screen. Fine. Another one is that all of your operating systems will have, like macOS, Linux and Windows anyway, they all have a kind of key store, okay? So this is where certificates, passwords are stored within the operating system, and Python has a library called Keyring. It's a third-party library that you can import, and then you can write and you can access that key store, okay? So yeah, it's called Keyring. I put a link to it there. It's a nice project. It's easy enough to use. But the most easy one that I'm going to use here is that we just ask for the password upon execution. Okay, so you just have to memorize the password. Obviously, don't write it down on a post-it note and stick it to your screen. But what that means is that you will just have a variable, like a placeholder, rather than having the password in your script. So that's what I'm running here. There we are. We've got an import for it's called getPass. So I've imported getPass there. It's part of the standard library. And then what I've done is I've called getPass to create this variable here of my underscore password. And then rather than having the password on screen, we have that variable. So this will run and it will create when I input my password, it will be stored by this variable, and then that will be retrieved and it will be sent. Okay, so if I run that, so I'm doing exactly as I did before. I do a highlight, blue line, yep, shift, return. Okay, and now we see this box. If you're running this on a terminal, then you will see that you have to type your password into the command line. It won't appear on screen, which is a nice thing. So, okay, so I logged in successfully there. I've got my login or cookie jar and the logout. Fine. But there's a trade-off between security and usability, as I'm sure you're aware. Now, the most secure network is one that's down, of course. But so for the rest of this video, rather than typing in the password each time, I've already shown you the password. You know, it's admin123. For all the rest of the examples, I'm just going to use the password on screen. But don't copy me if you are writing important code, or if you're writing any code. You know, follow best practice from the start, and that's to use some different way to get those passwords out of your scripts. Don't be lazy with that like I have done here. I'm just doing that because it's really boring to watch me type in a password each time. Okay, so next up, task 1.3. Now we're talking about hierarchy and whitespace. Now the reason for this is that the code that I've been running so far, this all just sits, so it's all up against the left side, right? So this all sits, what that means is that it sits in the global namespace for Python. So all of this will be run sequentially. The script is just going to run from top down. So we've got our IP address, then we've got our session created, and we've got our post, and we've got our logout, okay? And it will, each line will run in turn. The thing is with Python, if it hits an error, by default, if it hits an error, it's just going to end, okay? So that will be an issue from what I have already described about when there's only so many cookies. So we don't want to create an issue where we have where we're locking ourselves out. That's something that we really want to avoid. But if we run everything and it's just in global, there could be a problem if we log in and then we have some other calls and something goes wrong with those calls before we log out. So we need a way to make this more robust so that we will always log out. And the way that we can do that is by introducing some hierarchy. Now, hierarchy in different namespaces, so where you can nest some code and run it at different times and these kind of things. You do that with whitespace in Python, okay? So what by whitespace, it's just a tab or 4 spaces. It doesn't have to be that, but you have to stick to, so if you're going to use 2 spaces, you would have to always use 2 spaces, I believe. And you can't combine tabs and spaces in the same script, okay? But the standard practice is to use a tab or a 4 spaces, and that creates our white space. And what that does is it creates a hierarchy here. So the way that this will work is that I've introduced some extra functionality here to allow us to not just run everything global sequentially, but to actually log in, and then even if we hit an error, we're going to log out. So the way that this works is that this is all in global, then we have try. So what it does is it will try to run this block here. So this is nested, okay? We hit try, then we do our login, we've got our print to screen, then we pop out and we go to finally, and then we will log out. So we've got another block there, okay? So we have hierarchy from global to nested with these different blocks. And if I run that, so I'll do shift run. Okay, so it looks exactly the same. We've got a login, we've got a cookie jar. Now the function that what's actually happening behind the scenes is actually quite different. What is printed to screen is exactly the same. So to prove what's going on here, to show what would happen if we were to hit an error, I've actually introduced an error. So I'm going to print a bogus variable. It's called bogus. Let's run this. This will create an error. So shift return. And you can see this. So we've logged in, and so it was between login, we hit that error, and Python just ended, okay? So it hasn't logged out. It hasn't sent that logout call. And that means that we haven't returned our cookie. Now, and you can see here we get this ugly message. We've got name error. Now let's run that again. But what will happen here is that we will run in global, we will try to run this block here, the login. So we're going to log in, but then we're going to hit bogus, but that isn't going to end the scripts, because so that the error is going to be hit in the nested block. We're going to pop back out, and we're going to hit finally, and then we're going to finally run this other nested block, which is the log out. So even though we hit the error and that will show up on screen, we're still going to log out. So if I've highlighted that and I do a shift return, there we see. So you still got the error on the screen, but you've got the log out, the all important log out. Okay. And so this is really nice. Like I said, this talk is about some hints and tips that I think would be useful for someone when they're starting out. And this is something that when I learned it, I was very much like, crikey, I wish I had known that from the start, because I kept locking myself out, I should say. Right. Okay. So, and you could say I've put in an extra step here actually. So one of the things with this is that this is quite ugly, isn't it? Having this printed to screen. We don't need to have that actually. We can handle the errors, these exceptions, okay? And that's only a couple of lines. So this is another nice kind of hint for when you're writing some code against an API, which isn't the absolute basics, but it's really nice to incorporate. And that's to handle, it's called exception handling, okay? So what we've introduced is just 2 lines. I've put except name, so the type of error was a name error, as you can see there. And then so what that means is, like, if this block runs and it hits an error, so it hits a name error, sorry, we're going to handle that. And rather than that just be printed to screen, we're going to print this line that I've got here. Oh no, you hit an error, and then it will tell us the type of error. Okay, so if I run, and then finally we're going to log out. So if I run that, you will see, okay, so we've got our login, we've got, oh no, so we're still hitting an error. We've got the name actually of the error, which is really nice to give us that extra piece of information, so you avoid all this red ugliness on the screen if you know that you're going to get those errors. Right, so let's move on and get some data. So we've got our login, we've got our log out. Now we're going to actually grab some more information. So what are we going for? We're going for firmware, like I did with the Swagger already. And you can see here, I've created a variable there. So I've logged in, I've created a variable for the firmware, and I'm going to send a get call. And then you can see we've already seen that from Swagger where the suffix is firmware. Then, of course, finally, we're going to log out. So we'll run that. And there you can see all the data is printed to screen. We've got the current version, the primary version, all of these good things. Right. Now, the thing is with this, it's pretty ugly how this is returned. So it's just in a big block. If there's lots of data, that's really hard to read. So what you'll see is a lot of people will use something called pretty print, okay, which makes it easier. It makes it prettier, because it will create the structure. So if there's a comma, it will go to the next line. I think is one of the basic things that pretty print does. So if we run that, actually I've imported that here, and you can see, so rather than printing to screen, you might want to think about pretty printing to screen if you've got lots of data, and it makes it that much prettier. So as you can see, so this is the same data, this is the same call to firmware. So rather than it being this big block like this, you can see you've got a new line for each comma, which, you know, with a big block makes that that much easier to read. Okay, so the type of data that is returned from these REST APIs is JSON. Now, it's JavaScript object notation. Okay, I think all of the Aruba APIs, except maybe one, returns JSON. So this is the the most popular way for our APIs to return the data to you. Right. So what's important about this? Well, it's structured data. Nice thing about that is that, so if you were doing something like automation using SSH, doing some screen scraping, so essentially like you're using NetMiko to log into an API, and then you're doing some show commands, the data's coming back, but it will all be as a string. Okay, so it'll be a data type, it'll be a string, and that means that it will have all the headers and the columns and the dashes and the hyphens that are all good because the show commands are supposed to be humanly readable. But that's not what we need. We need our code to read these outputs. So a really nice thing is that rather than having to parse the strings, structured data can be parsed that much easier by our code. And JSON is structured data. So that the type that it is that it comes back as key value pairs. Now, a nice thing about this is that Python understands JSON. Okay, so with only a few lines of code, what we can do is we can take the JSON and then we can convert that into, so it's deserialized, I believe. We can convert that into a Python object that we can start playing around with, then start interacting with within Python. And the Python data type that JSON is translated into is a dictionary. So this is a key value pair, the dictionary. Okay, so all coding languages have something like this. It might not be called a dictionary, but that's what Python calls a key value pair. So the way that it's structured is like this. So you've got a key and a value. And the way to get the value, so the value is the interesting information. Okay, that's the thing that we need. So like the firmware, if we scroll up, the firmware that we're actually running, so the label, like the current version, okay, that's the key. But the important information, the actual image that's running on the device for the current version, that's the value. And the way that you get the value, so the important information, is that you call the key. Okay, so if we call the key, so if we know what key we need to call, we can get at the value. So that's going back to the three important pieces of information where I said the third one being the type of data, like the structure of the data that's going to come back. If you got that off the Swagger, essentially what you're doing is you're getting the keys so that you can get the values, right? And the way that we call the key to get the value is with square brackets, and then we put the string of the key. So this is an example here where I've converted the JSON that comes back. We will call that with current underscore version, that key, and then that will store that in a variable for us, and we can then, like I said, do something with this. So once that data is within Python and we can create a variable with it, then we can play around with it like we can any variable within Python, and I can print it to screen. But printing to screen is like the most boring thing that you can do. You can do much more with this. That's one of the real powers of Python, like all of the different third-party libraries and the functionalities that you've got here. So you can do things like put it in an Excel spreadsheet, you can put it in an email, you can post it to a Slack channel, you can open a ServiceNow ticket and put the image data in there. It's all about getting the data. Once you've got that, that's just the first step. That's what we're doing here. Printing to screen is kind of the most boring thing that you can do. Right, so let's actually do that though. Let's go ahead and do the most boring thing that you can do, which is to print it to screen. So I do Shift Enter. Okay, there we are. So I've created this. So rather than having the data like this, I've parsed out the value that I want by calling the key, the current version, and then I've put that into a sentence. Let's move on then, because this is just getting the firmware. Let's go in. We've already done that via Swagger. Let's do something else. Let us, so I've got two devices, as I mentioned. We're going to get LLDP, so a low-lying protocol that allows you to get a lot of information about your neighbors. Really useful. You can get that, of course, via the API. Different URL in this case, so it's still a get, and here it is. So it's per interface. I've got my interfaces 1/1/1/1. I'm going to get my LLDP neighbor information, and I'm just going to pretty print that to screen. Let's highlight that and run it, and there you see. So if this wasn't pretty print, it would be a big block, but you can see a lot of information. That's one of the things with this API. You can get a huge amount of data back. Okay, but the point is, it's not like a show command. You're not supposed to be the one that's going through and parsing this data. You only do that once when you're writing the code. Subsequently, once you've got your code, it's the code, it's your computer that's doing the heavy lifting for you. Okay, so this gives us a lot of information: chassis ID, MAC address. We've got the chassis name in there, so that's the host name of the neighbor, and we've got the lots of useful information. Right, so what I'm going to pick out here, I'm going to skip this actually. I wasn't going to mention it, but I'll skip it. The parsing is a little bit more complex than I'm going to show here, because you have to unpack it a bit more, because it's nested in here. But I don't want to get bogged down in that for this video. Essentially, all of the code is here of what I'm doing. I just need to go an extra step. It's not a simple call for parsing the JSON. But what I'm going to do is I'm going to pick out the chassis name, and I'm going to pick out the chassis ID and the MAC address, and I'm going to put those into a sentence. So rather than having this, I'm doing the same thing again, and you will notice that actually interacting with an API, a lot of it is really repetitive. You're doing the same thing. You're essentially getting the JSON, finding the information that you need, and then doing something with it. It's this. Once you've got the basics, it's the same thing over and over again. For the different types of data, or whatever you want to do with that data. Okay, so let's run this. You can see, so what I've done is I've taken that data from the big block, and I've printed to screen my neighbor, and then I've got my MAC address. So you could then put this, like I said, this is the most boring thing that you can do. You could create an Excel spreadsheet, put that in there, and have some kind of store for the MAC addresses, for example. Okay, now we need to move on and get a bit more ambitious, because so far all we've been doing is interacting with a single device. So taking that single IP address, creating a variable out of it, putting that into our URL, and then sending our calls to that. What we need to do is take multiple IP addresses from our network and create calls for all of those programmatically in our code. So how are we going to do that? Well, we need to take a detour into Python land, because we need to encounter a different data type. And this is we've already encountered dictionaries, and this is going to be lists. Okay, so a list, just like a shopping list in the real world, it's a way of storing data. So the data that we can store in a list is any of the data types within Python. So you can have strings, you can have a list of integers, you can have a list of dictionaries, you can have a list of lists. So it's pretty open. Another important point to remember is that it is ordered, and the pieces of data stay in the order, okay, when you recall them. So the first piece of data on the list, that will stay there by default unless you change it around. It doesn't just come back. So when you call the list, the first piece of data stays the first piece of data, the last piece of data stays the last piece of data, and everything in between, okay? Another important point is that it is indexed, so each piece of data has a number against it, so you can recall them by calling the number, but it is 0 indexed. Okay, so humans start counting at 1, but Python starts counting at 0. So the first position on a list, which we might say, oh, that's number 1 on the list, that's actually 0. Okay, if you want to call that, that's 0. The second is 1, the third is 2. Okay, so just bear that in mind, and I'll show you an example actually here. So I've got an example of a list. This is just a really simple list of strings. Oh, the way that we designate a list is with the square bracket. So I've got a variable here. I've created a list. It's 4 strings, and it's just the string of 1, 2, 3, and 4. What I'm going to do is I'm going to call data, so strings from that list, and I'm going to print that to screen. And the way that I've done that, so my list, so we put the name of the list and then the index, and as I said, starting at 0, so 0 is going to be 1 in this case, going to be a string of 1, and position 1 is going to be 2, you know, to make it nice and simple, obviously. So I'll do a shift enter and run that. There we go. So the first item on the list is 1, the second item is 2. Fine. Now, how do we go through the list then? So what we can do is, because everything stays in the same place, we can access that in turn. So this is what's called a loop. Now this is pretty powerful. I found it quite difficult to kind of grasp this to start with, but actually it's just one line. You take the list and then you do, it's called a for statement here. So we've got for item in list. So this is the name of my list. And this is more like a placeholder actually. What happens here is that, so it doesn't have to be item, it could be X, it could be anything. It's just a name for a position on the list. And it acts like a placeholder, so that will loop through the list. Okay, so it's also called a for loop. Right, what it does essentially is that it goes through this list, so my underscore list 1, and it takes the item in turn, and then it will print it out. So the relevance is that it will visit the 0 position, it will see the string of 1, and then item will store that and it will print it to screen. Okay, so it will go like, first of all, we go through, we hit the 0 position, print that to screen, then we go through. So this is where it's looping round. So it will go to the next position, print that, and it's going like this with the code, right? So it's essentially like looping through. It's iterating over the list is another way. So if I run that, there we see each one gets printed in turn, okay? I've given an explanation about what's going on there. Now the power of this though isn't just going through the list and just printing it out. The cool thing about it is that you can then do conditional. So you can do, if you see this in a list, then do that. Okay, and this is the example that I've got here for my for loop. I've taken my list and I've put in an if. So if we see the string of 2, then rather than the string of the word 2, we're going to just put the numerical 2. We're going to print that to screen, and then everything else I'm going to take. It's all lowercase. I'm going to make it uppercase. So I'm going to adapt the data when I print it. Now it's really important to remember as well that the list isn't changed by doing this. It's just what's going to be printed to screen. So what I've done there is, when this is finished, I'm printing to screen the list so you can see it's not changed, even though what we print out is going to be different. Okay, so I'll shift return this, and then you can see, so everything's in uppercase because I've said if it doesn't match the string of 2, then create upper. So we got 1 in upper. Now 2, we hit this, and then instead of the string of 2, we printed the numerical 2, and we've got on, and finally you can see that the strings in the list haven't changed. Okay, so the list is unordered. The list is unchanged, I should say, sorry, and the order is retained. But you can add in some logic to the list, right? Which we'll go on to why that's important at the moment. Now, okay, let's come back from Python land and let's have a look more at networking then. So how can we use this? So this is how we can take our multiple IP addresses and feed it into our code. So we can create a list of our IP addresses and we can run a for loop. I've called it an IP, but yeah, don't get confused with this. There is no relevance between what this is here, because this is just a string, and what this is here. It's more like a placeholder, okay? And lots of people put in lots of examples I've seen, they just put X, which is kind of confusing in itself in the for loop. Right, so if I run that, what we'll do is we'll print the IP addresses in turn. So shift return, you can see the different IP addresses. Now, this is the relevance. Let's go back to what we were doing before, where I said we want to interact with multiple devices. So we can take the list, we can interact with, we can feed the IP addresses in turn. If we run, if we have a list and a for loop, we can take the list, the different IP addresses, we create a for loop here, which will put in, so we've got the IP, it will put that into the URL instead. So we will do our login, and what am I doing here? I'm getting the firmware, and then I'm going to log out per the different IP addresses in my list, and then I'm going to loop. So the first one will go 101, so it's this first IP address. We'll loop around, so everything's nested in this loop. We will go through, we will log in, the IP address will be embedded there, we'll go and log out, and then it will go back up to the top, and it will go to the second position in the list and run through that again. Okay, so that's how we can get to multiple devices. And it doesn't have to be 2 IP addresses, of course. It can be 1,000 IP addresses. It'll take quite a long time, but it could be 1,000 IP addresses to do this. You just need to know about the power of the list and the for loop. Okay, let's run this one, and there we are, logging into 2. That's live devices that are just sat over to my right here, and I'm logging into these devices, getting the different firmwares. We can see we've got different versions of firmware on there. Okay, now what I'm going to do, what's this next one? Okay, I'm going to get some extra information. So not just the firmware, we can do different calls, so we can get the host names and we can get the firmware versions that they are running, and then put that, you know, as though you were going to store this information. And really, we've not gone that much further on from the basics that I started with. So it's only a few extra lines of code, but the functionality is that much more powerful because we're going to multiple devices, we're getting the host name, or we're getting the firmware version. Okay, so let's run that one. There you can see. So now I've got the device name and the firmware version. And like I said, printing to screen is the most boring thing. You could then get this information, put it into you know, a spreadsheet, put it into a Slack channel, these kind of things. Now, to finish up, okay, so jumping onto the final example that I've got in this short presentation, I am going to bring it all together, and I'm going to create a version of code that I want to know that my devices are running, okay? And it's the latest version of code. So what I've done is I've created a string of the latest version of code. It's 3000. I've called this a variable of the conservative release. So that's what I want my devices to be running. I'm going to do a for loop with my different destination IP addresses. I'm going to get the versions, and then I've put some logic in there. So like I had with the loop before, where I was going to check, okay, so is this true or not? I'm going to run that against my code to check whether my firmware is the conservative release or not. And if it's not, I'm just getting this right, if it's not, I'm going to print to screen to say, because to be honest, if you had like 500 devices, you don't need the name of the devices that are running the correct version of code, do you? You need to know about the ones that aren't running the right version of code, because those are the ones that you need to run a remedial action against. So what I'm going to do is I'm just going to print to screen the version, the device names of the devices that are running the wrong version of code. So if it's not running 3000, print it to screen. If all of them are running the right version of code, then just so that the code doesn't bomb out and we don't see anything, if they were all running the right version of code, I would print to say a nice friendly message to say all devices are running the correct image. Fine, so let's run this one. I know full well that one of the versions of code on this is incorrect, so we will get a hit on this one. Right, there we are. So this device is running the wrong version of code, and then that tells us. Okay, so I know this is just a YouTube video, but this presentation had to fit into 45 minutes because it was a live presentation with an introduction and all this kind of stuff. So I had to go very quickly through this, and I couldn't go much further than this. But what I was trying to do is I was trying to give some hints and tips about how you could interact with the API using things like, you know, bit of security, learning how to not lock yourself out all the time with a hierarchy, with a try and finally, how to interact with multiple devices. And why I went for this one is because a couple of years ago when I was at an event, a chap came up to me and he said, I have a whole bunch of switches that I don't have network management across at the moment, and I need to know about which ones are running which version of code. And so that's why I put this example together. So it's not, you know, mass network automation. This really is just the start of things. But this is, you know, it's not that, well, it's not particularly advanced Python, but it is pretty powerful. Okay, not for 2 devices. But if this was, you know, 100, 200 devices, you can get the versions of code. You don't have to. Lots of people will have network management platforms that are running this, but maybe not all of them. So this is a way that you can interact, and you see, you can get the data off of the API with only a few lines of code. You can say, I want it to know whether these devices are running this version of code or not, and then so where we can go with this is not just to print it to screen. You can then think about how you could go for the next step. So what if a device is running the version of code? Can you then set off, of course, you can set off some code, some alert, which would then prepare the code, download it as the secondary image to the device, ready for a window for the device to reload onto the correct version of code. Or you could just have the data, you could have a warning to say, you know, this device is running the wrong version of code that can go off, and you can have an alert, an email, you can have a ServiceNow ticket, because ServiceNow has got an API and we can send JSON to ServiceNow to raise this ticket. So there's lots and lots of places where you can take this, but the basics, you know, we've been walking through the foothills of how to get that data. Once you've got the data and you understand the basics of interacting with an API programmatically, that's the first point. Like I said, a lot of it's really repetitive when you are interacting with an API. It really is all about getting the calls, knowing the URLs, knowing the data, and then it's the next stage. Once you've got the data, once you've, you know, created your dictionary or your list, you can create your conditionals and these things, and you can fire off these next steps. So that's where the automation comes in, because you're not running each thing manually. You're stringing these different steps together, going through them programmatically and creating an automation pipeline. Okay, so that is the wrap up for this. I hope you found this video useful. I'll put all the links in the description for that are required to access this. Please do leave a comment if you want to see more of things like this. You know, it's a different format from what I've tried before. Do have a go with the Jupyter Notebooks. That I think they're really useful for explaining concepts such as this. Like, comment, all of those good things about the channel. I'm going to lie down in the darkened room after running through all of that. My name is Joe Neville. Thank you for watching, and goodbye.